Electricity powers nearly every aspect of modern life, and one man helped make that possible. Nikola Tesla's revolutionary work on alternating current transformed the way energy is generated and transmitted across the world. His inventions reshaped modern technology, yet many of his greatest achievements remained unrecognized during his lifetime. How did this extraordinary visionary change history forever?
Nikola Tesla was born in 1856 in the small village of Smiljan, where his remarkable curiosity appeared at an early age. Instead of simply enjoying toys, he was fascinated by understanding the hidden mechanisms inside them. This relentless desire to uncover how things worked would become the foundation of a career that changed the history of electricity. But his greatest challenges were only beginning. Tesla possessed an extraordinary ability to visualize machines entirely in his mind before ever building them. According to historical accounts, he could mentally test and refine his inventions with remarkable precision. This rare gift allowed him to solve engineering problems in ways few others could imagine. Soon, his remarkable talent would take him beyond his homeland and toward the world's greatest scientific opportunities.
While studying engineering in Graz, Tesla became fascinated by electrical machines and their limitations. Watching a direct current dynamo in operation inspired him to imagine a completely different approach to generating power. That single observation planted the seed for one of the most important innovations in electrical engineering. The world had no idea that a revolution was already taking shape inside his mind. Tesla realized that electricity could create a rotating magnetic field without relying on inefficient mechanical commutators. This elegant concept would become the foundation of the modern alternating current induction motor. Today, the same principle powers countless machines, from household appliances to industrial equipment. A single insight was about to transform the world's electrical future. In 1882, Tesla joined the Continental Edison Company in Paris, where he quickly earned a reputation as an exceptionally talented electrical engineer. Repairing and improving direct current systems gave him invaluable practical experience, but he remained convinced that a better solution existed. His ambition soon led him toward an even greater opportunity across the Atlantic. America was about to change his life forever. In 1884, Tesla left Europe and sailed to the United States with little more than his ideas and engineering skills. He believed America would offer the opportunity to turn his bold visions into reality. The journey marked a decisive turning point in his life and career. Awaiting him was a meeting that would shape the future of electricity and ignite one of history's greatest technological rivalries. Soon after arriving in New York, Tesla joined Edison Machine Works, where his engineering talent was quickly recognized. Although both men sought to advance electrical technology, they held fundamentally different ideas about how electricity should be delivered. Those opposing visions would soon evolve into the famous War of Currents. The future of global power distribution was about to be decided. The debate between direct current and alternating current soon became one of the greatest technological rivalries in history. While direct current worked well over short distances, alternating current could efficiently transmit electricity across entire regions using transformers. This advantage would ultimately reshape the world's electrical infrastructure. The competition was no longer about inventions, it was about the future of civilization. In 1888, Tesla introduced the induction motor, a machine powered by the rotating magnetic field he had envisioned years earlier. Its simple and efficient design eliminated the need for brushes and mechanical commutators, making it more reliable and easier to maintain. The invention became a cornerstone of modern industry and remains one of the most widely used electric motor designs today. It was the breakthrough that proved alternating current could power the future. George Westinghouse recognized the enormous potential of Tesla's alternating current system and secured the rights to develop it commercially. Together, they transformed a brilliant scientific concept into a practical technology ready for large-scale use. Their partnership accelerated the adoption of AC power across the United States. The next challenge would prove its superiority before the entire world. At the 1893 World's Columbian Exposition, Tesla and Westinghouse demonstrated the remarkable capabilities of alternating current on an unprecedented scale. Millions of visitors witnessed an entire fairground illuminated safely and efficiently by AC electricity. The event convinced the world that alternating current was ready to power the future. One final challenge remained: the immense force of Niagara Falls. In 1895, the Niagara Falls Power Project proved that alternating current could deliver electricity efficiently over long distances. Soon afterward, power generated at the falls reached the city of Buffalo, marking a historic milestone in electrical engineering. Tesla's vision had become a practical reality, changing the way the world generated and distributed energy. The age of modern electric power had truly begun. The Tesla Coil demonstrated how high-frequency alternating current could produce powerful electrical effects through resonance. Although it was originally designed for scientific research, its principles influenced the development of radio technology, wireless systems, and high-voltage engineering. Even today, the Tesla Coil remains one of the most recognizable symbols of electrical science. Tesla's dream of transmitting energy without wires was only beginning. In Colorado Springs, Tesla conducted groundbreaking experiments with high-frequency electricity and wireless transmission. His research advanced the understanding of resonant circuits and electromagnetic waves, laying important foundations for future wireless technologies. Although many of his ambitious goals remained unrealized, his experiments inspired generations of engineers and scientists. His next vision would be even more ambitious: to connect the entire world without wires. Wardenclyffe Tower was designed to advance long-distance wireless communication through Tesla's innovative high-frequency research. He also envisioned broader possibilities for transmitting electrical energy, although those ideas were never fully demonstrated on a practical scale. Financial difficulties eventually brought the project to a halt before its full potential could be tested. Even so, Wardenclyffe remains one of the most ambitious engineering projects in the history of electrical science. Financial setbacks eventually forced Tesla to abandon the Wardenclyffe project before it could be fully realized. Yet he never stopped exploring new scientific ideas, continuing to design and imagine technologies far ahead of his time. Although many of his later projects remained unfinished, his influence on electrical engineering continued to grow. His greatest legacy would ultimately be measured not by unfinished towers, but by the technologies that transformed the modern world. Today,
Nikola Tesla's ideas continue to power the modern world through the alternating current systems that supply electricity to billions of people. His inventions transformed electrical engineering and helped shape the technological foundation of modern civilization. More than a century later, his legacy remains a reminder that a single visionary idea can change the world forever.